Hey everybody, and welcome back to Algebra 2 online. So the plan for today is to talk about, I alluded to it in the last video, the harder version of dividing polynomials. So things like this. So we talked about last time, if you divide a polynomial by just one term, you can literally just divide that term into everything, right? But here we are dividing this polynomial by x plus 2, so 2 terms. And whenever you have 2 or more terms, you're going to have to do it actually with really long division. But I'm also going to actually show you today a trick to make the long division a lot easier, basically. So I thought it'd be good, honestly, to start off and just do actually a long division problem. So just to kind of remind you, because you probably haven't seen this in a long time. So let's just say we have like 127 divided by like, I don't know, like 11 or something. When we do this long division, right, the weird thing is we kind of look to the left of the number in here first. So we look at the 1 and we're like, can 11 go into 1? No, it's too small. So then we go over and we got the 12, and then we think, can 11 go into 12? And yes, it can. So we put a 1 up there, right? It goes in one time. And then we multiply the 11 and the 1, and we put that down there, and then we subtract. And subtract, you get a 1, and then you bring the 7 down, right? And you do it the same idea. It basically just restarts. So now you're kind of done looking up here, and you look here and you're like, okay, can 11, go into 1? No. 11 go into 17? Yes. How many times? Well, one time. And then you multiply, this 1 and this 11, and you get 11 down there, and subtract, you get 6. And then it's good. One of the things I hate actually from elementary school, students write this R6 thing. You should not write R6. That is, you need to write what it is. This remainder, is related to this number. And the way it's related is it's 6/11ths are left over, right? So don't write like R6. That means that doesn't help us. You need to know the number that you multiply 11 by to get 127. And it's 11 and 6/11ths. So if you do 11 times whatever that mixed number is, which I also hate mixed numbers, but 11 and 6/11ths, that should equal 127. So that's basically what we're literally going to do, but we're going to do it with symbols, with x's, rather than numbers. And then I'm actually going to show you a shortcut to doing this even easier. So let's just get into it. So I'm going to set this thing up. I'm going to put 4x cubed plus 2x squared minus 4x plus 12 there. And then we're dividing into it by x plus 2. All right. And same kind of idea. I look to the left, okay? And honestly, this is kind of one difference. I'm going to look to the left of this one too. So I'm going to look at x, just the x, and just the 4x cubed. And I'm going to think, how many times can x go into 4x cubed? All right? And you can make it perfectly get to that if you put 4x squared on top, right? So I'm going to put, I'm also just kind of OCD, so I'm going to line things up. So I want 4x squared up there above my x squared. So when I do this out, you're going to see x squareds lined up, x cubes, x's, and then the number. And so this, just like we did over here, the next step was to multiply. We're going to multiply it by this thing. But one other kind of difference is we have to distribute. So we're going to multiply 4x squared by x and also 2. So if I do that, 4x squared times x is the 4x cubed. I made that work, right? And then 4x squared times 2 is 8x squared. And then the next step was subtraction. And probably the most common mistake with this stuff is students don't remember that you're subtracting all this stuff. Like here, it doesn't really matter as much because you just like, they're just numbers and we're pretty good at knowing like this whole thing is subtracted from that. But sometimes students write the negative and then they forget that you're subtracting all of this. So this symbol right here, like you wouldn't do 2 plus 8 and get 10. You're going to do 2 minus 8 and get negative 6. All right, so we'll do that subtraction. This should always just go away, okay? And then 2 minus, because it goes away because we like set it up that way with the 4x squared. Then 2 minus 8 is, like I said, negative 6x squared. And then just like in long division, you bring this thing down. And then honestly, it all just restarts again. So we put a number up, or not a number, we put a expression up top that we multiply x by to get negative 6x squared, which would be negative 6x. Then we multiply negative 6x and this thing, right? And we would get negative 6x squared, and then negative 6x times 2 is negative 12x. Then we subtract. And again, these should always go away because we set it up that way. And then negative 4 minus a negative 12 is 8x's. And then last, bring down the 12 and do it one more time. So this time, x times 8 is going to be 8x. And then 8 times 2 is 16. And then you subtract. And 12 minus 16 is, oops, just messed up my colors. What was I saying? So 12 minus 16 is negative 4. And now there's like nothing else to bring down, so we're in the remainder part. And just like before, we make a fraction. But our fraction also looks kind of weird because it's going to be like the negative 4, and then it's over, like before it was over 11 because of this 11. Here it's going to be over this. So we're going to put negative 4 over x plus 2. And so literally, if you do it, you're going to, if you multiplied x plus 2 times this thing in red, you literally get this thing under here. It really would work out. That's it. That's how we basically do polynomial division. And this is going to be very helpful for us to find like roots and different things with higher order polynomials. So I just wanted to do another one, just kind of quick here. So I'm going to set it up. We get that. And then again, 3x times something is 3x cubed. And that something would be x squared. Then I multiply, and I would get that. And then I'm going to go ahead and subtract, and I would get that. And then you basically just pull down the next term, and you do it all over. So I'm going to pull down the 10x. And then 3x times negative 2x would be negative 6x. So now I'm going to multiply, and I would get that. And then again, I'll just subtract, and I would get 12x. And then one last time, bring this down. And then 3x times 4 is going to be 12x. So I'll put my 4 up there. And then I multiply 4 by 3x plus 1 and get that. And then I'm going to subtract. And I get negative 7 left over. So I'm going to do the same kind of thing and just kind of put that in a fraction and say, what I have left over is negative 7 over 3x plus 1. And you can think of it literally as plus negative 7 over 3x plus 1. So, like if this had been a positive, you would like literally just put the positive number over this. So you're just tacking on another term. That's a fractional term, just like we added really, because really like the way this works is it's like 11 plus 6/11ths right there. That's kind of the long way to do it, but there's a much easier way. And this is honestly useful, and there's times where we're going to actually need it, and I'll say something about that, but most of the time, you're going to do it a different way. So this is the thing that you'll actually do most of the time, something called synthetic division. So I'm going to walk through actually the first example we did and show you how synthetic division works with that example. So we know like what to get. We know we should get this thing, this answer. And I'm going to show you basically a shortcut to long division that gets you the same result, but just way less writing. And just one important thing to note, probably the most important thing to note, synthetic division is going to only work if you're dividing in like a linear term, like ax plus b. And really important thing is that the a needs to be a 1. Okay, so if we were dividing this cubic by like a quadratic, you would literally just have to do long division. But it really wouldn't be that long because you're dividing x cubed by an x squared then, and so there won't be many steps. So the only time long division feels really long is if this thing has a high power and this is a power of 1, because then you're going to have like a lot of, like these different subtractions to get down to, the right power. So, if we're dividing in a power of 1 to a power of 3, we're going to have our highest power be a power of 2. So synthetic division really only helps you with those linear terms. But it's very helpful in those because it takes the long version of these division problems and makes it a lot less long. So honestly, in the synthetic division, the setup step, that's what I call it, is probably the longest step. So this is basically how I think of it. So for the setup, and I'm going to try and like color code all this. So we write what I call the root in the top left corner of my work. Okay, and the root, what I'm talking about is we have a factor, a linear factor, and so from a linear factor, we know we would know the root would be -2. So even though actually we know this problem already doesn't divide in cleanly, so like this actually isn't a root for this polynomial, it's not a factor, and so then -2 is not a root. We still like kind of look at this and we're like, really what we're going to use synthetic division for is like, we're going to test to see if things are roots. But we're going to like kind of guess that -2 is a root. So we're going to just stick it in a little box off in the corner. We're going to use it. And then the next part of this setup here is we're going to write down all the coefficients of the polynomial you're dividing into, and we're going to bring down the first that should really say, coefficient. Okay, so what that would look like is, this is my polynomial I'm dividing into. We're just writing the coefficients, so 4, 2, -4, and 12. And then I'm going to bring down the first one, 4. All right, and I'm going to put a line actually here. All right. And that is like the setup, all right? And then step 2 is where we're going to kind of, so like in long division, step 2 is to multiply this thing by this, okay? So here I'm multiplying the root by -2 and the first coefficient, which is this 4, right, that I brought down. And we're going to place that result under the second coefficient, all right? So I literally just do -2 times 4, or like this 4, it doesn't matter. -2 times 4, and I put that right there. So the red step is literally just that red -8. Then, green step, we're going to add vertically, okay? So I add these vertically, and I would get -6. That's it. And then basically we're just going to repeat until all the columns are filled, which I don't have this color that I can use, so we're going to call it the purple step. And then I just repeat until all those columns are filled. So I do -2 times this one, -6, I'll put that there, and then I'll add, and then -2 times this thing, and I'll put it there, and then I'll add. So it's basically multiply and add, multiply and add, multiply and add. So that's going to look like negative 2 times negative 6 is 12. Then I add negative 4 and 12, and I get 8. And then negative 2 times 8 is negative 16. And then I add, and I get negative 4. Okay? And technically, we actually just finished. This is the division is done. The long division is done. And if you look at this line relates to the first problem. So notice 4, negative 6, 8, negative 4. 4, negative 6, 8, negative 4. This line represents the results of the division, and it's basically just 1 power less than what we had as our max, right? So if we're dividing a cubic by a linear term, the result's going to be a quadratic. And this will always represent the square. In this case, it would represent the squared, then the x term, then the number, and then this last column will always, always, always represent the remainder. So, my answer, we already had it before, but this is 4x squared, this is minus 6x, this is 8, and this is my remainder of negative 4 over x plus 2. And it's literally just long division, but we made the whole process way less writing. This is just so much less writing than this, right? And one thing students always ask is, when we do long division, in the step where we've lined them up, and then typically we subtracted, we didn't add, right? Here I'm saying add vertically, right, to get like this number, and this number, and this number. And the reason we're adding and not subtracting is because we put what I call the root here, and the root is a negative 2 versus a positive 2, right? Like as we know from quadratics, it's the opposite of this. So the way to compensate for the opposite sign there is to add instead of subtract. Basically, then there's like a double negative thing going on, and you're back to basically subtracting. This negative here accounts for, or this adding vertically accounts for the negative 2 versus the positive 2. And that's basically it. So very, very, very handy trick. And I'm going to show another example here so you can see some more of this. Okay, so if we had x cubed minus 27 and we want to divide it by x minus 3, this one is a little trickier, okay, because of the structure of this polynomial that we're dividing into. So the table that we're going to set up won't just literally look like 1, negative 27, like, and so it won't just look like that. Like that's kind of what you might think this setup would look like. And honestly, most of it's pretty good, but you need to account for all the terms right here. And in order to keep all of our ducks in a row, sort of, we need to put in some placeholders. All right. And I know we need placeholders because I know polynomials don't just go x cubed and then the next term down is the number. The next one down is x squared, and then there's an x, and then there's a number. So what we really need is a 0, x squared, a 0x term, and then a minus 27. And this 3 is still, that should be there. This 1 should be there. We bring the first one down. And this is just the root that we're getting out of that, okay? And so then we just multiply and add, okay? We do 3 times 1, we get 3, and then we add 0 and 3, and we get 3. And then we do 3 times 3, we get 9, and then we do 0 plus 9 is 9. 3 times 9 is 27. Negative 27 plus 27 is 0. And we know that, if we're dividing a linear term into a cubic, again, this would be a squared term at most. then an x, then a number, and then a remainder. Always, always, always will be the remainder over here. And so what we're getting is, the result is x squared plus 3x plus 9, and then there's no remainder. So this is actually kind of an important result, because this is basically saying now that x minus 3 times x squared plus 3x plus 9 is x cubed minus 27. And more importantly, it means that 3, which we had called a root, like root in question mark sort of, is actually a root. Okay? Basically, it divided in perfectly with no remainder. Just like if we take 12 and we do long division with 3 or something, we get 4 up here, and then we get no remainder. Like, we know that 3 and 4 are, they are the factors of 12, or, well, 2 factors of 12. This x minus 3 is a factor of x cubed minus 27. And more importantly, 3 is actually a root of x cubed minus 27. So this gives us like a little taste of where we're going with all this stuff, because what we could do to fully find all the roots of this cubic is do long division like this. Then we find out that 3 is a root, and then we could just factor this quadratic. And once we factor this quadratic, we find its roots, right, which we've done a bunch before. And now we have 1, 2, 3 roots of the x cubed thing. So this is kind of our first, it's going to be our first method for how we find the roots of a cubic, or really any higher order polynomial. But more on that later. So right now, just making sure we can do the division. All right. All right. So I want to do what I sort of was just talking about with this one instead. So I'm telling you that one root of this cubic is -2. And then I want to find the other 2 roots, right? And we can do this with division, right? If we know one root is -2, then that's what I'm going to put in my corner. Then I'm going to do my long division. 1, 2, 4, 8, really my synthetic division. That's my setup, right? Multiply and add. -2 here, add those, you get 0. -2 times 0, you get 0. 4 plus 0 is 4. And then -2 times 4 is -8. And then we get 0. And that's, good, because we were expecting to get no remainder, because it is a root, we were told. All right, so now we have a quadratic, x squared plus 4, right? And x squared plus 4 is, a very nice quadratic to find the roots of. Like, you can either do quadratic formula, or you can just do it this way. You could set this equal to 0, move that over, and we know that the 2 things we square and get -4 are plus and minus 2i, right? And so this cubic has 3 roots, okay? And the 3 roots are, I'll just write down, so x cubed plus 2x squared plus 4x plus 8 has the 3 roots of -2 and then plus and minus 2i. One thing we're going to talk about a lot more coming up is the amount of roots you have always equals the biggest exponent. So when we were doing quadratics, right, we were getting things like this x squared has 2 roots. They might be repeated, and you might get the same number twice, but you'll always get the same amount still as the biggest power. So x cubed has 3 roots. You'll see x fourths and x to the 5s, and like x to the 5 is going to have 5 roots. So this is one method that we can use if we know one root of a quadratic, cubic, here. Then we could do long division, reduce the problem to a quadratic, solve the quadratic, and now I know my 3 roots, okay? Just one more example I want to do in this, and I really want to do it just because a lot of times people get a little confused by this symbol. So this is a very common way to write division, actually. It's a very computer sciencey way to write division, because that -1 exponent that we talked about last video, that just means flip the side of the fraction it's on. So really this is a very shortcut way to just write 4x squared minus 33 and then times 1 over 7x plus 7, or just 4x squared minus 33 divided by 7x plus 7. And nope, I dropped a 2 in all of these, sorry. And so a lot of times when you're coding things, you want just it's easier to type on one line. You might just type this instead of having to do this kind of thing. So this is basically just the long division problem now that I'm going to set up. So it's one that has some placeholders, right, with the coefficients. So we have 42, whoop, sorry, let me fix that. So we got 42, and then x squared, and then we got no x's, right? But another weird thing in this problem is we have our first case where a is not 1. So I told you that to make this work, this synthetic division trick, and to actually just quickly explain why, when we do, if a is not 1, we can't just bring this term down the way it is, because, here 7 times 6 is 42, so the first term would be a 6, and not normally we would just bring the 42 down. So it's really easy to fix it if it's not 1. So if I just write this over here, so we literally just need to make that a 1 in front, in the bottom, so we're just going to multiply by a 7th, and that'll make the, 7 divided by 7 is 1, but we can't change the problem, so we need to multiply by a 1 here. And so really the division I'm going to do is 42 divided by 7, which is 6x squared, and then minus 33 over 7, and all that divided by x plus 1, okay? And now I can go and set everything up. So I have a root of -1, and then I have 6x squared, no x, and then negative 33 over 7 as my number. Bring the 6 down. And so this is actually what I was saying. We know it should have started with a 6 down here, because 7x times 6x is 42x squared. But anyway, so -1 times 6, -6, add -1 times -6 is 6, and then add those, which if you just get a common denominator of 7, you would get 9/7. And then from that, we could write our answer. So we have 6x, right? This is x number, this is x number, and then the remainder. So we have 6x minus 6, and then this one that looks a little weird, 9/7 over x plus 1. And if you don't like the fraction and a fraction thing here, which you shouldn't, I would just want you to multiply, by 7 over 7, which is a 1, so you can do that. And then you can get 6x minus 6 plus 9 over 7x plus 7. So that is it. That is the division of, this thing by